All right, let's go over the Chapter 2 test review. First things here, we are going to identify and define the essential components. So our essential components here are quota, weights, and players. So those are our three. To start off with, a quota, if you remember, that is the number of votes needed to meet or to pass a motion. Okay? Now, weights, when we talk about weights, that's the number of votes a player has. And when we talk about players, those are the people, whoever, corporations, people, departments, whatever you want to call it, that have a vote in the weighted system. So players over here, people who have a vote in the weighted system, weights the number of votes a player has, and then quota the number of votes needed to pass a motion, which you can see here already. Let's see. All right. Let's go down here to a couple examples here, and for each one, we're going to identify the quota, the number of players, and the weight. So the quota for part A is 35. It's always the number in front of the colon. The number of players, if you count out, you got 1, 2, 3, 4, 5, 6, 7 players here. So number of players is 7. That's the number of numbers after the colon. And then we've got the weight of the fourth player. So weight of fourth player here is just go to the fourth player. In this case, there's 1, 2, 3, 4. The fourth player's weight in that first weighted system is 8. For part B, again, we will do the same thing. So the quota is going to be 20. The number of players is going to be, if you count it out, 1, 2, 3, 4, 5, 6, 6. And then the weight of fourth player is going to be, let's see, 1, 2, 3, 4. It's going to be 3, just the fourth player's weight. Really, that just means that the fourth player has 3 votes in the system. All right, so that's kind of number one. Number two, we've got quota, and we're talking about the quota and how it relates to the voters. So the quota determines if a coalition have met the quota, if it's winning or losing. The minimum is going to be 50% and then round up. The maximum is going to be less than or equal to the quota. We're going to change the quota to meet the new criteria or majority statement. And then we're going to find the percentage that a quota represents. So, for example, here, given the weighted system of, we got 20, 8, 7, 4, 3, 2, 1. 20 is the quota, and then the players that follow. So we've got, looks like 6 players. Most of the time, those players are going to be numbered in order from least to greatest. What is the least number of votes for a quota? So we've got 8, 7s. If we just add all of those up, when it says least number, that's going to be the minimum. So add all of the weights up, which we get 25, and then divide it by 2, and then that's going to equal 12.5, right? Well, we can't have 0.5 of a vote, so we round that up to 13. What is the number of votes for quota of 25? So what are the number of votes for a quota? Most number of votes is going to be the entire weight. So in this case, we just take what all of them added up to be and equal that. So part C then says, what is the quota to have at least 3/5 of the majority? So at least 3/5 can be 3/5. We take what all of their weights equal, we multiply it by 3/5, and we get 15. So 15 is going to be at least 3/5 of the majority. What is the quota to have more than 3/5? Well, if 15 is to have 3/5, then just go up one more and there's 16. 16 is going to be more than 3/5 majority. What is the quota to have a 3/4 majority? Just take the total, multiply it by 3/4, you get 18.75. The problem is, again, we can't have 18.75, so we're going to have to round that up to 19. What whole percentage does the current quota represent in the system? So in this case, our quota was 20. We know that 25 is going to be the entire system. So what we need to do is take 20 divided by 25, which is really going to reduce to 4/5 or 0.8. It wants percentage, so 80%. And it'll say whole percentage just in case it's a decimal, it wants you to round up. All right, let's talk about dictators, dummies, and veto power. A dictator has a weight that is greater than or equal to the quota. Why is this? Because if they have a weight that is greater than or equal to the quota, then they can meet the motion without anybody else. Therefore, they are a dictator. A dummy is not needed in any winning coalition to be a winning coalition. Meaning that if we took this player out, the coalition would still be a winner. Veto power is a player that is needed or critical in every winning coalition. Okay, so those are our three. Let's see, maybe I can make that look a little bit better. There we go. There are our three that we're going to look at here: dictators, dummies, and veto power. Part B, identify a dummy, dictator, or veto power. So in this case, dictator, dummy, and then veto. So a dictator would have to be somebody who has, all the power. And if you look at our quota, it's 27. None of the weights meet that. So there are no dictators. A dummy, if you go to every winning coalition, so if we're going to list out our winning coalitions, right? We've got to list out the people who win, right? So if we take this and do 11 and 9, and we add their votes together, they still don't equal 27, so we got to add somebody else in. Okay, if I add 8 in, now we go above 27, that's a winning coalition. Another winning coalition is if I take maybe 11, 9, 8, and 5, which is also called the grand coalition. Now, in this case, those are the only two winning coalitions I have, because if I drop 11 or 9 out of any coalition, there's no way that our weights are going to equal that. So the only one who would be a dummy, well, actually, there is no dummy because 5 is not in this winning coalition up here. Now, veto power would actually be 11, 11, 9, and then 8. And the reason that we have that, we could also say that that's player 1, player 2, and player 3. And the reason we can say that again is because, they are needed in every winning coalition to win. All right, same thing down here in part B. I won't go through each example. I'll let you kind of work through maybe C, D, and E. But here, if we were to list the winning coalitions for part B, remember that our quota here is 12. So if I was to take 9 and I was to take, I don't want that bolded, so hang on. So if I was to take 9 and 6, right, their sum is 15, which exceeds that quota, so they're a winning coalition. If I was to take 9 and 3, their sum is less than 12. Actually, no, 9 and 3 is 12. So I want to make it clear that that is also a winning coalition because their sum equals the quota. Now, 6 and 3 doesn't work, but 9, 6, and 3 does. Okay? Now let's talk about dictator. None. Again, why? Because none of their weights exceed the quota. Dummy. Is there a dummy in any of these? No, right? 3 is needed in the 2 coalitions below, but it's actually not in the top one, so we can't say it's a dummy. A dummy is somebody who is in every winning coalition and is not needed. Okay, so no dummy here. So none again. And then veto power. Veto power is somebody that is needed, critical in every winning coalition. 3 is not in the first winning coalition, so we can't consider them. 6 is not needed in the second winning coalition, so not needed there. But 9 is in every winning coalition and is needed in every coalition, so player 1 or 9. They're the same person. Player 1 just has 9 votes. Okay? I'll let you look through C, D, and E. Let's talk about coalitions. Coalitions, the definition of a coalition, right? What is the definition of a coalition? It is a group of, players. That's basically it. It's a group of players. It doesn't have to be a winner, right? There are different types of coalitions. There's the winning coalition. Now that group of players meets the quota. There's a losing coalition. Now their coalition does not meet the quota. And there's the grand coalition. The grand coalition is all the players all in one group. Sequential coalitions are just like what we did at the very end lesson, and that's when they are listed in order, like player 1, player 2, player 3, player 4, player 5. Player 1, player 2, player 3, player 5, player 4, right? We had all those different sequential coalitions. Determine the total number of possible coalitions. We can do that by doing n factorial. If you remember that, n factorial is the number of players factorial, and that gives me the total number of possible coalitions. Actually, no, that one is for sequential. Let's correct that, n factorial for that one. The total number of possible coalitions is 2 to the power of n and then minus 1. That gives me the total number of possible coalitions. Not sequential, but just possible. So write out any 3 winning coalitions here for this first example. Answers may vary, but essentially if we have to have 35, let's start off by taking the largest number, which is 12. If we then take 7 and add that in, now we're sitting at 19. If we take, let's see, 3, put that one. Actually, you know what? Why don't you start with this? Always start with the grand coalition. If it just wants you to list any of them, the grand coalition is going to be a winner because it's got everybody in there. So you can add all their sums up. Let's see, if we did that, we would have, there's 10, there's now 30, 46. So 46 is all of the weights in there. Let's list another one here. How about 12? Now throw in that 8 because that gives me 20. Let's do 9 and 1. Now I've got 30, and then throw in a 6. Why not? Because now we exceeded. And let's do one more. Same 4 starting numbers, 12, 8, 9, 1. But now let's throw in that 7 from earlier, and there's our winning coalition again. Okay? So there's 3, any 3 winning coalitions. Answers may vary. How many total possible coalitions exist? Well, first of all, we've got 1, 2, 3, 4, 5, 6, 7 players. So 2 to the power of 7, and then minus 1. If we do 2 to the power of 7, remember that's 2 times itself 7 times. You can grab Desmos for that. That's not a huge number, but it's not a small number. So let's see, 2 to the power of 7, 128 minus 1. And this is why I didn't make you list all of those out there. There are 127 possible coalitions. You might not want to list all those out. How many sequential coalitions exist? This is 7 factorial, and remember that is 7 times 6, oops, not shift, 7 times 6 times 5 times 4 times 3 times 2 times 1. There is your 7 factorial. You can also do that in Desmos. I believe there's a function for you to do it on your Apple calculator, but it's 5040. We did a problem like that earlier. These are the problems that we have a little bit of trouble with. Let me get back up here. Consider a weighted voting system of 5 players. So you didn't like these because they don't give you numbers there, but you know you've got 5 players. And when it says the total sequential coalitions exist, that's just 5 factorial, right? Or 5 times 4 times 3 times 2 times 1. And we actually don't even need to do times 1, but I'll put it up there anyway for the purpose of definitions. And we will say 5 factorial, which is 120 possible total sequential coalitions. So you don't really want that many to write out. How many total possible coalitions exist? Again, this is just 2 to the power of 5 and then minus 1. And so if we did 2 to the power of 5, we get 32, right? 2 times itself 5 times, and then minus 1. Now we're looking at 31. How many possible coalitions exist in the system that do not include player 3? So if we exclude player 3, now we're looking at 2 to the power of 4 minus 1, right? We've eliminated a player. So if we get rid of that player, now it's just 2 times itself 4 times, which is 16, and then subtract 1. Now we've got 15 coalitions that do not include player 3. How many possible coalitions in this system do not include player 2 and player 3? Well, this is easy. Again, just drop it, right? There were 5 total. Now we've taken 2 out, so it's 2 to the power of 3. So 2 times 2 times 2, which is 8, minus 1, which is 7. There's 7 total possible coalitions that do not include player 2 and player 3. How many do include player 2 and player 3, right? How many do include it? Well, if we know that there are 120 and 7 don't include it, now we're looking at 113 that do include player 2 and player 3. Oh, I'm sorry, 31. I was back on another problem. That was a lot. I was a little confused there. So 31 minus 7, which is going to put us at 24, I believe, do include player 2 and player 3. All right, now we're getting to the good stuff. Banzhaf power distribution, and then the last one there, which is going to be our Shapley-Shubik. So the definition of a critical player, we need to know that. Remember, a critical player is a player who is needed in every winning coalition, and then, or is it critical in every winning coalition? Calculate the Banzhaf power index. We got to be able to do that. So I'm going to give you a short one here. Right, perform a Banzhaf power distribution of, and we got 10 as our weighted system, 6, 5, 4. So here what we want to do is list out all of the winning coalitions first. So 6 and 5. Here's a winning coalition, right? Here's another one. How about 6, 5, and 4? Why would 5 and 4 not be a winning coalition? Because, right, we know that 5 and 4 does not equal 10. It's less than 10. It's 9, so that one doesn't work. All right, now I'm going to come up here, and I think I'm going to add a table, insert table, and I'm going to do a 3 by 3. The reason I'm going to do this is I'm going to have our player 1, which we know is, actually I should have done let me do this. How about we insert row or column to the left? So we got player 1. Player 1's weight is 6. We got player 2. Player 2's weight is 5. And we got player 3. And their weight is 4. So now we're going to do kind of that B sub whatever in. And when we do this, what we're looking at is how many times is that player critical? Well, 6 is actually going to be critical twice. 5 is going to be critical. Ooh, I missed a winning coalition. This is why you double check and do all of this. 6 and 4. So 6 is going to be critical thrice, 3 times. Player 2 is going to be critical, looks like 1 time. Player 4 is going to be critical 1 time. And then we're going to kind of do that beta, right? I'm not going to go in and add that Greek symbol just yet. I mean, it's fine. If you want to know how to do it, you can come over and I believe in Google Docs, you insert a formula or equation, and then there's our beta symbol. So I guess I can do that. That's not that bad. Let me put it up here. So insert equation. If you're doing this at home, here it is, beta. So now we're doing beta. Beta determines the Banzaf power that they have. And remember that it is the number of times critical over the total number of times, which is 3/5 in this case, which is going to end up being 60%. Over here, 1/5, which ends up being 20%, right? That's 0.2 or 20%. And this one is also 1/5, which equals 20%. If you're confused as to how I got my 5 there, it's because 3 plus 1 plus 1 is 5. That's the total number of critical players, or times that all players are critical. So player 1 is 60% Banzaf power, player 2 20, and player 3 20. All right. We could do the same thing over here for the next system. And let's just do it one more time. So let's see, 19, 9, 8, 5, 3. And 19 is our quota. So if I do 9 and 8, I don't know why this is underlined. Let's get rid of that underline there. 9, 8. And then if we look and I add 9 plus 8 together, we're looking at, 17, not quite there. So we got to put that 5 in. That now has a winning coalition. If we do 9, 8, and 3, 9 and 8, 17, plus 3, now we got 20. That's a winning coalition. Now, if we do 8 plus 5 plus 3, that gives me 16, which is not a winning coalition. So we have to have that 9 in there. And then if we look at any other kind of addition of 2, that's not going to work. No other additions of 3 are going to work. So we need to go in and add our grand coalition because that one does work. I'm going to insert another table here. This time I've got 4 players. So I'm going to have 5 up at the top, 5 by 3, because I'm going to have player 1, player 2, player 3, and player 4. So a number of times critical here. If we look, remember it's underlined, but and that's how we can define them. 9 is, all of these here are going to be critical players because every single one is needed to pass. Same thing here. All 3 of them are going to be critical players. Now, if I jump over to this system, 9 is definitely critical. If I dropped 8, I still lose. So 8 is definitely critical. Let's see, 9. If we drop 8, say we got rid of it, we got 9 plus 5, which is 14, plus 3, which is 17, so that doesn't meet it. So we need the 8. If I drop the 5, I've got 9 and 8 plus 3, that passes. If I drop the 3, 9 and 8 plus 5, that passes. So 9 is critical 3 times, 8 is critical 3 times, player 3, which is 5, is critical once, and player 4 is critical once. So now what we want to do is add in our beta, or a Banzaf power distribution. We can see that there's 3 plus 3 plus 1 plus 1, which gives us 8 total times critical. So 3 out of 8 here. And let's just leave them as fractions. That's kind of simple here. 3 out of 8, 3 out of 8, 1 out of 8, and then 1 out of 8. I like when it does that to it. So there's our Banzaf power distribution, and you can go through and make those fractions if you want, and then or decimals and then percentages. There you go. All right. So I'm going to leave you C and D to do. Not bad, not bad at all. There's 3 system and then a 4 system, but it's short. There's not a ton of winners there. Perform the factorials with operations. I like this one here because if I go 8 factorial, let me just write this one out real quick. If I go 8 factorial, what you're going to see here, there we go, is you're going to see 8 times 7 times 6 times 5 times 4 times 3, my times 2 times 1. But then if I do 5 factorial, let me go back in here. Why won't it let me? There we go. That's going to be 5 times 4 times 3 times 2 times 1. If you notice, 5 can cancel, 4 can cancel, 3 can cancel, 2 can cancel, and 1 can cancel. And essentially, what you're going to be left with here, let me go off to the side, is just simply 8 times 7 times 6. So you can cancel everything out to get to that point. In which case, because the 8, 7, and 6 were all left in the numerator, they stay in the numerator, and you get 336. The same can be done with any of these here, so make sure you go through and do those factorials. Shapley-Cubic power distribution, this is the last one we'll do, and the answers for all of them are underneath. But the Shapley-Cubic power distribution calculate the definition of a pivotal player is this player is needed in order to meet that quota. Calculate it here. We'll look at part A. So for part A, when we perform the Shapley-Cubic, remember 3 factorial tells me how many different sequential coalitions I have. In this case, 3 times 2 times 1, which is 6. Now we know, and I'm just going to create a table here to organize this. Let's just do 3 by 2 because that's 6. When we do our sequentials, we just really change the order of these players. So 10, 5, 2, but then the next one can be 10, 2, 5. And we're just essentially trying to order all of these out in different ways. And that's why we need that factorial. It tells us how many different ways we can order them. So 5, 10, 2 is a different order. 5, 2, 10 is a different order. And now we're going to put 2 in front. 2, 10, 5. And then 2, 5, 10. Completely reversed. So there's all of the different ways we can have a sequential coalition. There's all 6 of them. We can double check. When we find a pivotal player, we know that that player is when we added them all together. That's when we met the quota. So 10, 5, and 2. Notice that the addition of all of these equals our quota. So the last number that we add each time is going to be pivotal. That 2 is pivotal, that 5 is pivotal, and again, 10 plus 2 is 12 plus 5. Now we're at 17. That's the pivotal player. So the last player every time is going to be the pivotal player. And each player is last on this list twice. So when we do our Shapley-Cubic power distribution, it's going to be the number of times pivotal divided by total sequential coalitions. So 10 is pivotal, or player 1 is pivotal 2 out of 6 times, which is going to be 33.3%. And each of them are going to be this way. Player 2 is pivotal 2 out of 6, right? 2 times it was pivotal, 5 was pivotal there, here, and 5 was pivotal here. So again, 33.3% of the time. And then player 3, same deal here, 2 out of 6, which is 33.3% of the time. So there you go. You've got an example for that one, a reminder for this one. If you do have questions about this, here are all of the definitions and all of the answers that you want to have. Okay, they're all here. They'll match up what we did earlier, a little bit better organized here, but they're all here. Okay, if you've got any questions, let myself know or Mr. Coble know, and we will do our best to reach out and answer you quickly because I know you'll be taking this test tomorrow. All right.